Hey guys, welcome to today's lesson over balanced, unbalanced forces and how to calculate net force. Welcome everybody. It's Miss Driver. I'm here today to kind of help you out with a review of our last week's topic, which happened to be with forces. So let's go ahead and recap what we've done right here. Forces are a push or pull on an object, and these forces are indicated with arrows. Okay, so keyword there, arrows indicate a force that's being applied. So in everyday life, we have forces that are acting upon us. So with my beautiful little picture right here, we have gravity, which is a force that is pulling us down to the earth. And we also have something called a normal force, which is the ground pushing us back. This is why we're able to stay on the ground and not float off into space. And the key thing we want to talk about is the difference between balanced and unbalanced forces. So I use a very easy picture in how to visualize balanced and unbalanced. So what I normally use is a scale. So if a scale is balanced, it's equal on both sides. So for instance, this scale has two boxes that weigh the same and two boxes over here that weigh the same. So they are equal or balanced. What if I go over here to this scale? This scale right here has three boxes on the left side of equal mass and one box on the right side of one mass. So that means that the left side is greater. So therefore it tips my scales and it is unbalanced. Now when we talk about unbalanced, we're meaning that the forces, instead of weight when we're working on the scale, the forces are greater on one side of the object than the other. Okay, so here I have a scale. And let's say that my scale is representative. Here in the center is my object that I'm applying forces to. So what we're going to do is we're going to apply a force on one side of the object. Now my force is unbalanced because I have 1 Newton of force over here and no newtons of force over here. So my object is going to be moving in the direction that the force is applied. Now, if, for instance, let's say I want to then apply a force on this side of the object, I'm going to apply a force, and this is 1 Newton and 1 Newton. And now my force is balanced. We're going to keep this in mind when we start talking about forces being applied on objects and getting a net force. So in order to make this unbalanced again, I want to be able to have more force applied to one side of the object. So I'm going to tip the scales and add another force. Keep this in mind when we start doing our box equation. Let's talk about net force. Net force is the sum of all the forces on an object. But I'm going to give you kind of a life hack or a cheat sheet to this when we talk about forces. If my arrows, which remember arrows indicate a force, are going in the same direction, you must add those forces together. Okay? Now, if my arrows are going in an opposite direction from each other, we must subtract those forces. Now, here's a key thing. We measure a unit of force in newtons. So that's why you keep seeing this unit of N every time you're doing a project, because this unit of N right here, an assignment, is a Newton. That's a measurement of force. So if we're going to add forces, and we'll work with this box right here, it's because the forces are going in the same direction. I have 3 newtons to the right applied on this side of the box, and 2 newtons of force also applied to the right to this side of the box. So this right here, this force is a push. This force is a pull. Remember, because if I'm on this side of the box, I'm pushing it. Pretend that my hand is right here pushing this box. And on this side of the box, I would have to be pulling it in this direction. So because they're going in the same direction, we add 3 newtons plus 2 newtons gives me a magnitude, which is my answer of my number, which is 5 newtons to the, don't forget your direction, to the right. Okay, so let's come over here and let's look at our subtraction. Okay, so I have 10 newtons of force being applied on top of the box, pushing downward, and I have 3 newtons of force being applied on the bottom of the box, pushing upward. Now, because remember, if the arrows are going in opposite directions, I must subtract. So I'm going to take 10 newtons minus 3 newtons, and I'm going to get 7 newtons, don't forget your direction, down. Now we got down because there are more forces being applied on this side. So in this side, we check to see what direction our force is being applied, and we find out that it's being applied downward, so that's how we got the direction of down. Remember, newtons is our unit of force. So we're going to take a step back and look at everything here. So in today's video, you should have been able to understand that the net forces, if they are equal to 0, then that means that it is experiencing balanced forces. But if the net forces are equal to any other magnitude and a direction, then they are experiencing unbalanced forces, which is going to cause this to accelerate in a direction. And we're going to talk about that in your next videos coming up this week. Thank you so much for watching.